Okay, so in this video, we're going to talk about absolute and relative errors in binary, and we're going to use the floating point format to help us calculate these absolute and relative errors, which is something that you need to be able to do in an exam situation. Now, to help me out with this, I'm actually going to look at a number, which isn't a particularly large number, but will demonstrate the issue arising quite nicely, of 64.375. And if we were to write 64.375 out in binary, and we start with the 64 column, 64, 32, 16, 8, 4, 2, 1, and then after the decimal place, we know it's going to be a 0, half of it would be a quarter, and it's going to be an eighth. Now, if I do this and convert this into its floating point format, and if you don't know about floating format, you'll have to have a look at some of the videos that I've produced related to this topic. What I'm going to do is I'm going to move this back to normalize it, and I'm going to move it back to just here. So the final mantissa is going to be written out as 0.102467 1, 2, 4, 5, 6, 7 zeros, and then a 1 on the end. And it's not uncommon to only have a fixed position of 10 bits to be able to record your mantissa in. So what we can see here is that this value is essentially has been lost when I've recorded this. Now, I need to finish this answer off, so it's 1, 2, 3, 4, 5, 6, 7. So my exponent is going to go in as 0, 0, 3, 4, 6, and 7. So the final answer that I've actually got, if I were to then convert this back into its corresponding number, using the exponent of 7 here, I would end up with a value which would be 1, 0, 4, 6, 7, 2, 4, 5, 6. Yeah, so I'd end up with this number here, which would be 64.25. Now, that's not the number I started out with, but what I have now is a situation where I've got an inaccuracy in the values that I have recorded. So, there's two types of error that are calculated here. There's something called the absolute error, and there's something called the relative error. So I'm just going to clear the screen now, because I don't really need these, but you should have made a note of them down in case you did need them. But let's say I've got, and it will help me just to clear this for a moment as well. So in my situation here, I've got an answer of 64.375. That's the number that I wanted to record, and what I've actually recorded is 64.25. Okay, so the absolute error is actually very straightforward to calculate, in that it's just 64.375 minus 64.25 to give me an answer of 0.125. Okay? So that's the absolute error. It's simply the answer I started out with, subtracted from the answer that I've got, to give me 0.125. Now, the relative error is actually the absolute error divided by the number that I actually wanted to create in the first place, 64.375. So 0.125 divided by 64.375 is my calculation for my my relative error. Now, I will need a calculator for that, because I can't do that in my head. So 0.125 divided by 64.375 gives me a relative error of 0.0019, I think that was. And that is my relative error in relation to how much of the number that is to the actual larger number itself. So that's all about absolute and relative errors, and you need to both know how to calculate both in an exam.